In previous lectures, you learned how to read measurement results from log file in LTspice. In this lecture, I will show you how to read measurement data from log file into Python IDE. Now let me give you a quick demo. Let's go to the folder for this lecture. This is the schematic file in LTspice, and the log file is also generated, which contains all the measurement. So now we want to use Python to read the numerical numbers into Python IDE, given different measurement names. The most important module we are using is LTspice 3 MEAS.py. This is the module I developed just for reading the measurement data from log file. The application program is in read measure log.py. Let's go to Spider. Make sure you are in the correct directory. We open the application code called read measures log.py. You can see the code is very straightforward. This is the Python code to read log file into Python IDE. The first step is to import a Python module called LTspice 3 MEAS. I'm the author of this module. Then you define a variable called measure name list. It's a list of strings that are names of measurements such as output voltage average, output voltage maxima minima, output voltage underline T, output voltage underline derivative. The last two are just bad names for testing the code. VL2 and VL2X do not exist in measurement. This is just for testing purposes. Now let's run the current cell. So this is the measure name list. In the second cell, you give a string to the variable file underline name. This is the file name of your log file. And we use LTspice 3 measures.logGet class to create a Python object. We call it L1. If you run the code of L1.log_print, the whole log file will be printed out in the IPython console. Let's run the cell. You can see in IPython console, the whole log file just has been printed out. Let's go back to the folder and double check the log file. You can see every single line has been printed out. This is for your reference. Now we are very interested in this part, to extract the data from log file. The last step is to save measurement data as NumPy array called MEAS. It saves all the measurement from LTspice in the order of MEAS name list. If the measurement name is incorrect or cannot be found, the corresponding element in the NumPy array measurement will be 0, and the corresponding element in flag list will be false. Now let's try to run the last one. So you can see here in variable explorer, measurement is found as a NumPy array indexed from 0 to 6, consisting of 7 numbers. The last two numbers are 0 because they don't exist in the measurement, so the return number is 0. Now let's check the flag. This is a list of Boolean variables. If it's true, that means this particular measurement is found in the log file. If they are false, that means they cannot be found. Flag is a good indication of your finding results. And again, the variable names are saved as MEAS name list. The last two are just fake names that don't exist in log files for testing purposes. That's all for this quick demo. Now, let me give you a brief overview of the source code for LTspice 3 measures.py. It didn't take me too much time to finish it because Python is very easy and powerful. Let's open the module LTspice 3 measures.py in Spider. As you can see, the code is very short, just a few lines. First, we import two Python modules. The first one is called RE. It's for regular expression. Python has a very powerful module called regular expression that can do searching and extracting in a quite elegant manner. The second one is NumPy. We have been using it before. It's a module that handles all the NumPy arrays. Overall, the LTspice 3 measures taking log file and a list of measurement names as input. It will find the measurement and create a Boolean flag variables. First, it will convert measurement names into lower cases, and it will create a flag variable to save Boolean results for each variable in future steps. The function log underline print is to print out all the log files into Python IDE. The next function is called log underline data. Is to read every line of the log file using for loop. If the line begins with any measurement names, regular expression is used to extract the numerical results from that particular line, and it will save it to the variable measures. Also, the flag variable is updated to true if the measurement is found. Otherwise, the flag remains at false. If we revisit the log file, you can see. So overall, the software will first locate a particular line that's starting with the variable name. After that, regular expression is used to extract the numerical number from this particular line. That's all for this code overview. This is the reference I used for this presentation. I used Chapter 11, Regular Expression, from the book called Python for Everybody. I found it pretty helpful. You can find the same content by using the link here. Thank you, and see you next time.